Okay, ladies and gentlemen of trigonometry, we're starting Unit 4, and we're going to have a chopped down version of Unit 4. And so we're going to start with this, talking about your basic identities and kind of showing how one is proven to the other. So a lot of today is based on kind of one identity, and then we're going to kind of build from there. So the very first one is the Pythagorean theorem identity that you guys have seen before, and it's just with our sine and cosine. You've seen this back in Unit 2, but now we're going to take it a step further. So you need to be able to identify those things kind of as we go through. So let's start here. So you guys all recognize unit circle. Hopefully you guys recognize this. Okay, this was towards the end of Unit 2, to where, you know, if pi over 6, this was my x and y value right over here. Well, you figured out that if you go sine squared plus cosine squared, what happened? Well, this becomes 1/4, this becomes 3/4, so you get an answer of 1, which is what we've proven. And that's true all the way around the circle. And the reason for that is, if you realize that this all stems from the fact that this is a right triangle with a horizontal distance of square root of 3/2, vertical distance of 1/2. And then all you did was Pythagorean theorem. I mean, it was literally, a squared plus b squared equals c squared, except we knew that c was going to be 1, and 1 squared is just 1. So all you're doing is a fancy dressed up version of Pythagorean. So from there, we kind of come up with this idea that, you know what, sine squared plus cosine squared equals 1. All right. So how do we come up with this? Well, if we start with the equation of a circle, goes like this: x minus h squared plus y minus k squared equals the radius squared. Okay, so this is the equation of a circle. All right, but we know that h and k are usually the center of the circle. So in this case, it's 0, 0. And we know that the radius is 1. So all we're saying is x squared plus y squared equals 1. So we know that h is 0 and k is 0. And my radius is 1. So it becomes x squared plus y squared equals 1. Except we know in our unit circle that x is our cosine and y is our sine. Let's not use x, let's use theta. So I'm really saying cosine squared of theta plus sine squared of theta equals 1. Okay, and then all I do is just flip those two because I can do that. By the way, when you write it as squared, that's what it looks like. If you take cosine squared, you write it like this, saying that you're taking cosine squared. This means something different. So don't write it like that. You want to write it like that. That's your correct answer. So this is saying cosine of theta squared. That is what that is representing. Okay, so this, we have that it's 3/4, and then figure out the cosine given it's in the first quadrant. First quadrant, remember, everything is positive. So sine is 3/4. So if I go squared plus, b squared, cosine squared, that's going to equal 1. Well, that's going to be 9 over 16 plus y squared equals 1. So if I switch this into 16 over 16 and subtract that from both sides, y squared is going to be equal to 7 over 16. And then when I square root that, that's going to be square root of 7 over 4. So technically, whenever you square root, it's plus and minus, but you know it's in the first quadrant, so you're only going to take the positive. That's going to be your answer. All right. So, and you've done a few of these before towards the end of Unit 2. So same kind of idea. This time you're given cosine, but you're in the third quadrant. Third quadrant, for those of you guys that may have forgot, is down here. This is quadrant 3, where everything is negative. So your cosine is negative 1/4. So if I take sine squared plus cosine squared equals 1, you know that this is going to be negative 1/4 squared. Okay, so keep that sine squared theta, or you can switch it to x squared. It's for all intents and purposes, it's fine. So if I subtract this, this becomes 16 over 16 minus 1 over 16. So that's going to be 15 over 16. So sine squared theta equals 15 over 16. Square root everything. So sine of theta is going to be square root of 15 over 4 plus or minus. But I know I'm in quadrant 3, so I take the negative. Okay, these are things that we've done. These are things we've done in the past. I'm hopefully just kind of jogging your memory with this. Next thing I want to kind of draw your attention to, we've kind of emphasized this point pretty heavily, that cosecant is 1 over cosine squared. So if I go cosecant squared of x, that's the same thing as 1 over sine of x squared. And then, or just 1 over sine squared of x. Similar for this. One thing that we did not emphasize that we probably should more is cotangent and tangent. Please note that sine over cosine is tangent and cosine over sine is cotangent, because that's going to come into play. And if I square those, that's what the equivalent is right there. Okay, so in your in Schoology, there's a folder called Trig functions, or what's it called? I think it's called Trig. What's it called? Trig identities, and this is just one identity that we're working with here. All right. So let's talk a little about what we want to do. So this is your fundamental Pythagorean identity, and then from there we can build off of this. So from here, sine squared plus cosine squared equals 1. So just by doing 2 quick algebra functions, I can do this. So with 2 quick algebraic steps, we've got 3 different versions all saying the same thing, okay? So that is going to come into play. That's going to come in handy in about a minute here. So how we prove identity. So you don't need to write this down or sketch this down, but you should have a couple different things that you want to look at. Number 1, you're looking for algebraic things to do, and here's what that means. You want to either combine things or see if you can distribute or see if you can pull things out in common and things like that. Multiply by a version of 1 that you might not have thought about before. Or do obvious algebra, squaring, distributing, multiplying polynomials, blah, blah, blah. Or you can start looking for trig things to do. Realize that, sine squared x equals 1 minus cosine squared x. So you can swap those in. You can substitute there. And you can think of Pythagorean properties and then kind of keep looking at your answer to see what you're doing. Okay, we're going to go through some of these. So this is not a typical algebraic equation to where I'm doing things on this side and on this side trying to get them equal to each other. What I want to do is operate wholly on this side, and at the end, my last step should look like that side. Okay, so I am completely manipulating the left side and then trying to make it land on the right side. So if I start with this, the first thing I want to do is distribute this. So that gives me cosine theta secant theta minus cosine squared theta. So I'm going to distribute that. So now let's think about this. Cosine of theta. Secant is actually 1 over cosine of theta. Okay, so that's where this kind of comes in. So cosine of theta times 1 over cosine of theta. That's a fancy way of saying 1. Those cancel out. 1 minus cosine squared. So that becomes, well, 1, and 1, this will be one of the biggest ones you do. Instead of the 1, I'll put sine squared theta plus cosine squared theta minus cosine squared theta. I mean, some of you guys might recognize that this is the same thing, and that's fine. I'm just going another step. Instead of the 1, I'm swapping in this, and then look what happens. Plus cosine squared theta minus cosine squared theta cancels out. So that's what I'm left with, and that's what I need to have. Okay, so that's when it says verify the identity, that's kind of what it means. It's saying take this side and make it look like the other side. All right, so here, verify my identity. Secant and tangent. So I got to start thinking here. Secant is really 1 over cosine squared. Tangent is going to be sine squared over cosine squared. And I've got to make this look like 1. Well, if I look, cosine squared, here and here, I've got a common denominator, so I can put that into one fraction with the same denominator. All right, so then 1, I can rewrite that as sine squared plus cosine squared. And then I have the minus sine squared here, all over cosine squared. Well, now look what happens algebraically. The sine squared minus sine squared cancels out. I have cosine squared over cosine squared, which is just going to equal 1. All right, so all I'm doing is manipulating and rewriting things the way that, just a different way, and seeing what I can come up with. And a good rule of thumb here is try and get everything into sines and cosines, and then see what you can do from there. So here, cosecant is 1 over sine squared. Cotangent, remember, is tangent flipped over. So I have cosine squared on top and sine squared on the bottom. And I want to make that equal 1 somehow. Well, let's take a look at what I do here. So I've got, once again, I have sine squared, 1 minus cosine squared. And maybe you guys are starting to notice this. Every time I put 1, every time I see a 1, I'm swapping that in for sine squared plus cosine squared. And that's going to cancel out. So all I'm left with is this. Same thing on top, same thing on bottom. That equals 1. All right, so I'm putting it together in one thing and then showing how it simplifies. One like this, again, I'm breaking everything down into sines and cosines, and I'm trying to get to 1. So secant is 1 over cosine. Tangent is sine of x over cosine of x. So what I end up with is sine of x over cosine of x over sine of x over cosine of x. So multiply both by the reciprocals. Cancels, cancels. That also cancels, cancels. That's a fancy way of saying 1. Okay, so just kind of in a bigger way. This one's a little bit of a challenge because I'm going to separate this first. So I'm going to go secant squared x over secant squared x minus 1 over secant squared x. So here's kind of what that's going to look like. This becomes 1. This side is 1 over cosine squared x. All right, all I did was switch secant squared x out. So what this becomes is fraction within a fraction. I'm going to multiply top and bottom by cosine squared x. So that all becomes 1. So I get 1 minus cosine squared x. Okay. So then that becomes sine squared x plus cosine squared x for 1 minus cosine squared x. That cancels out. That's what I'm left with. That's what I need to get. Okay, so this is just manipulating things to make them look a different way. So you can take a minute and check this one out, see what you can do. I'll do it real quickly here, but hit pause, see if you can do it, and then come back and check your answer. So I get that. So then if I multiply everything like that, actually what I can do, maybe not multiply the whole thing because that's an algebra thing to where I would have to do it to both sides of an equation. But what I can do is I can multiply just this one times another sine. So that becomes sine squared theta over sine of theta plus cosine squared theta over sine of theta. So then I put this together and look what happens. Sine squared and cosine together equal 1 over sine of theta, which rewritten is just going to be that. Okay, so again, broke down cotangent, combine those, rewrote this first one, which a little bit of a trick, but you can still do it. Because I'm trying to get sine squared and cosine squared on the same place. Because if I put those together, I know I can get 1. Okay, so that's what you're looking at. Try to do for 4-1 is just play around with that and see what you get. 4-2 is kind of going one step further with that. And it's not too brain-breaking, but there's a couple different things you need to be aware of. So these might take a little while longer for you to put together. So you want to make tangent plus cotangent. They're not squared. And make it look like cosecant and secant. Again, I'm only manipulating the left-hand side. So finding a common denominator would mean I'm going to multiply by the other denominator. So I'm going to multiply the first one times sine and the second one times cosine. All right, so I multiply this side by so this first one I've got sine over cosine, but this denominator is sine. So I multiply this by sine. The second one, I'm trying to multiply both by cosine. So I end up with sine squared over cosine theta sine theta plus cosine squared cosine theta sine theta. Same thing on the bottom, just written in a different order. So then I can put this together, and I'm hopeful that you guys are starting to see that sine squared and cosine squared together just give you 1. And then I can split those into 1 over cosine times 1 over sine, which is written another way would be secant theta cosecant theta. And all I would have to do is flip those around to get my identity. Okay, a few more steps, and you got to be kind of clever there, but it's still very doable. So this one is not much of a challenge as you would think it is. Just because in about 2 steps, you'll see why. The first thing I'm going to do is I'm going to split this. So I'm going to go sine of theta over sine theta, cosine theta, plus cosine theta, sine theta, cosine theta. And it's kind of interesting what happens when you look at that, because what you want to have happen actually does have happen. These two cancel out, and I'm left with 1 over cosine of theta. Cosines cancel out, I'm left with 1 over sine theta, which is secant plus cosecant, which is exactly what I want. So all I did was split my fraction, and I'm there. Let's look ahead. This one's interesting because if you notice, you have a tangent squared, tangent squared. So what I'm going to do is pull that out of there and consider that to be kind of in common with those two. So that's going to be 1 minus sine squared theta, like so. So tangent squared becomes sine squared. Let me rewrite that in a better way. Sine squared over cosine squared. And then one of the shortcuts that I'm hoping you kind of recognize is that can be rewritten as cosine squared of theta. This all stems from that idea of sine squared plus cosine squared equals 1. So cosine squared equals 1 minus sine squared. You know, that's just algebra, just subtracting something over the other side. So all I'm doing is swapping that in. But then look what happens. When I do that, I have cosine squared. That all cancels out. I'm just left with sine squared of theta. That's my answer. That's all I'm doing. All right, so this one obviously proposes a few issues. So, but let's kind of look at this. I'm trying to get to tangent sine times cosine, to where I have sine squared and tangent squared. So here's kind of what I'm going to do. I'm going to rewrite. You see how I have this is all one term and then this is two terms? I'm going to rewrite, and this is going to seem kind of counterintuitive, I know. But this is what I'm going to do. Instead of sine squared, I'm going to rewrite it as 1 minus cosine squared. And I'll show you why I'm doing that in a second. Because my next step is going to be to distribute this. So tangent theta matches up to that. But then I've got tangent of theta times cosine squared of theta. Okay? So now, here's where I'm going to leave the first tan theta alone because that's what I want. Then I'm going to rewrite this second one as what it represents. Sine over cosine. So now I've got a cosine on the bottom and 2 on the top, so that cancels out. So now I've got tangent of theta minus sine theta cosine theta, which is what I want. All right, and this is this is not a intuitive step doing this, but you got to realize that sometimes you got to do that, especially when you look. I went from one whole term to 2 terms, something I had to do there. Okay, last one. This is where you kind of play around a little bit first. So hit pause, give this one a shot, and then come check. The first thing I'm looking at is that bottom part because that should stick out to me a little bit. So tangent, I'm going to switch that to sine over cosine. Okay, over this 1 minus cosine squared, I'm automatically recognizing that as sine squared. So that's going here, that's going there. So now, to get rid of fraction within a fraction, I'm going to multiply both the top and bottom by cosine. So that's going to cancel out. All right, so I'm going to have sine of theta, cosine of theta, over sine squared. Wait, hold on. I'm not going to have that. What am I doing? Sine squared theta, cosine of theta. So now what you have is 1 sine of theta over sine squared of theta. So this I'm going to cancel out. So that's going to cancel out, that's going to cancel out. So I have 1 over sine theta cosine theta, which becomes 1 over sine theta times 1 over cosine theta, which becomes cosecant secant, which flip-flopped is the same thing, which is exactly what I want. All right? Okay, so that's what you're looking at for 4.1 and 4.2. Play around with those, and then we will talk soon, and then shortly after this, you'll have a quick quiz on this.